Good afternoon and evening. This is meteorologist James Longworth here with Dynamic Weather Agency LLC. In today's video, we'll be talking about severe weather today across portions of the central and southern Great Plains, where storms will develop later this evening along the dry line with all hazards possible today. Severe weather will continue tomorrow across portions of the eastern and southeastern parts of Texas and eventually moving its way into parts of the central Gulf Coast region. More severe weather will be possible again on Thursday across portions of Florida and the Carolina coast. But first, before we can continue with today's video, I do encourage you guys to hit that like button down below and subscribe to the channel if you haven't already. It does help out that YouTube algorithm, allowing my videos to be viewed by more people, allow me to do my part as a Weather Ready Nation ambassador with the National Weather Service in creating a Weather Ready Nation, promoting severe weather safety, and letting you guys know about all the hazards for today. Also, head on down to that description section down below of this video where you can find the links to our social media along with our website, dynamicweatheragency.com, where you can find more weather information, including forecasts, radar, and much more, including our tropical weather tracker on over there. So that's something you guys should be checking on out. And last but not least, I do encourage you guys to head on over to our Patreon page where you can help support this channel, allowing me to continue to make videos here on YouTube, such as some of the storm chasing footage you can see on our channel, along with funding the chasing and research here at Dynamic Weather Agency, supporting website upgrades, and much more. I put everything that I get back into this channel and into this company, along with being able to be a Patreon subscriber. There is exclusive perks and exclusive content to our Patreon subscribers. So please head on over there. So let's get into today's video. And starting off with today's video, I do want to talk about the weather over the past couple of days. So let me get this on up for you guys. So taking a look at this. So this is yesterday's storm reports. We did have that slight risk of severe weather across parts of the Appalachian Mountain region and moving its way off into the mid-Atlantic. You can see there was quite a bit of wind reports yesterday, about 60 wind reports across this area where a convective line system moved on through. And this is that same system that created that severe weather the day prior across Missouri and Illinois. And I really want to talk about that right here. So here's the storm reports from the 24th, where we had that enhanced risk for severe weather. You can see all those tornado reports across parts of northern and northwestern Missouri, across even a few isolated reports across central Missouri, and then again across parts of southeastern Missouri into west central Illinois. And we were covering this storm system live. And like I said, there was that enhanced risk for severe weather yet on the 24th, and that enhanced risk was extending all the way from northern portions of Arkansas, central and southeastern Missouri, across parts of southern and west central Illinois. And with this risk that we had in place, all hazards were possible, including tornadoes, the potential for large hail, and of course the potential for damaging winds as those storm systems merged into a convective line. Now, we were live the whole entire time. Here's some screenshots I took of the radar from our live stream. And this is a little bit later on near the nocturnal portions of the tornado event. And you can see we were monitoring three supercell thunderstorms moving across portions of basically southeastern Missouri into what was west central Illinois. And you can see those three velocity couplets with that one storm system north of Annapolis, that storm system near Ironton and north of Fredericktown, with that storm system near Annapolis moving up towards Fredericktown, where we saw a tornado there, and then that other storm system up along the Missouri and Illinois border. And here's one of the 3D analysis of that storm system near just south of Ironton, moving towards Frederickston. You can see that tornado here with that 3D analysis we were able to do while we were live as we were tracking these tornadoes. This is a radar-derived parameter that we're looking at here, and this is called correlation coefficient. So what correlation coefficient is showing us is how similar objects are in the atmosphere, given the correlation in the name. So basically, raindrops are falling in pretty much the same shape and size. And then when you have things like 2x4s, tree branches, shingles, and other things for that a tornado is able to pick up and loft into the atmosphere, that is a drop in correlation. So where we have those blue values right there, that is tornado debris being lofted into the atmosphere, being picked up by the National Weather Service radar, the WSR 88D dual polarimetric radar, and is able to determine that we have non-meteorological objects in the atmosphere, such as tornadic debris. Doing a cross section on that, we can see how high that tornado is lofting that debris into the atmosphere here, and you can see debris being lofted up well above 20,000 feet, up to about 25 to even almost 27,000 feet, just below 30,000 feet by this tornado that was west of Fredericktown, just south of Ironton. And then we were looking at that major tornado, that one that moved through St. Mary. Again, you can see that correlation coefficient, and take a look what happens. Hold on, we have one more image right before that. Here's a 3D analysis of that tornado. Again, you can see that tornado right here. And after that tornado moved through St. Mary, moved towards the Chester, towards Chester, and I believe it was Randolph County in Illinois, you can see how big that debris signature grew as that tornado moved over a more populated area where there was some more trees, and grew in size too. We had there's some video. You can see that stovepipe tornado moving into St. Mary, becoming more of a wedge tornado as it moved towards the northern portions of Chester. You can just see how big that debris signature is with this tornado, and that debris signature is pretty much wider than the town of Chester itself. Again, you can see that tornado debris signature as we do another cross section here, being lofted up to just about 20, a little bit higher than 20,000 feet into the atmosphere. Now, getting into the severe weather threat for today. So today, the Storm Prediction Center does have a enhanced risk across portions of the central and southern plains, with a slight risk stretching well northward, and the marginal risk all the way up into portions of Nebraska, all the way down to the Texas-Mexican border. So a big area of severe weather expected today across portions of the central and the southern plains today. Now, taking a closer look at some of the places in that enhanced risk for today, this is going to be the greatest area for severe weather today. Woodward, Elk City, Oklahoma, Lawton, Wichita Falls, Abilene, Mineral Wells, and Brownwood, all located within that enhanced risk for severe weather today. A couple places just outside of that in that slight risk include Wichita, Dallas, Waco, and San Angelo. Now, as we take a look at our hazards for today, all hazards for severe weather will be possible today. For tornadoes, that's going to be confined mostly to the western portions of Oklahoma, a small portion of extreme southern Kansas, and a portion of northern Texas, where that 5% probability is, with a lower percent chance for tornadoes surrounding that region. Again, the threat for hail today will be, again, confined to that western portions of Oklahoma, and most of the greatest threat for that tornadoes and isolated large hail threat is going to be around storm initiation, when those thunderstorms are more isolated in nature, because storms are going to initiate pretty late this evening. Instability will begin decreasing as we move into the nighttime hours, as we lose some of that heat trapped into by the atmosphere due to radiational cooling. Some of that will be trapped by some clouds moving on over the area and a stable layer developing. But for the most part, most of that energy will begin to decrease as the sun goes down, where then it will be transitioning more into a straight line wind event. As you can see, here's that straight line wind event wind probability for today by the Storm Prediction Center. There's a 30% contour for that today across portions of Oklahoma down into northern Texas and stretching up into parts of southern Kansas and stuff. So that's going to be pretty much the threats for today. Now, what do we have going on synoptically? Well, synoptically currently right now, you can see there's a broad area of low pressure developing over portions of eastern and northeastern Colorado today, with a warm front draped across southwestern Kansas into western Oklahoma, with a dry line extending all the way from western Oklahoma down through West Texas, down towards the Texas-Mexican border. And that's going to be the main initiating factor today for severe weather, is going to be that dry line, as that dry line continues to push to the east towards that very moist, unstable air mass today. And that's where that's going to be the forcing factor for convective initiation later on this evening. Now, taking a look at our visible satellite imagery, this is the GO-16 satellite, visible satellite imagery. And across Oklahoma, you can see clearing in the clouds, a few scattered and clouds moving on over the region still, but a lot of sun's able to still penetrate through that. And that's going to help heat up that surface across parts of Oklahoma, even across parts of northern Texas, and that's going to help destabilize the atmosphere in that boundary across the area, allowing it for a conducive environment for severe thunderstorms and allowing for that dry line to continue to push its way to the east, where we're going to see convective initiation off of later on this evening. Now, taking a look at the forecasted surface analysis, again, we have that low pressure system trying to develop across portions of eastern Colorado. Warm front draped across the region with that dry line to the west of Oklahoma and across western Texas. And like I said, that's going to be our main initiating factor for the day. As we move throughout the day, that low pressure system is going to undergo some cyclogenesis as a jet max and shortwave moves on through the region. And this is going to help promote upper level divergence across the area, allowing mass to be removed from the column, decreasing the surface pressure across the area, along with the deepening of the trough axis as another jet max moves on into the trough axis, causing thermal troughing and cold air advection behind this low pressure system. That's going to help create that cold front that you see right here on this graphic right here. Now we have a well-defined, developed cold front to the west behind the dry line. And then we're also going to see, due to some upper level ridging and that warm front continue to lift off to the north, nice warm air advection out ahead of this low pressure system, increasing diabatics out ahead of that low pressure system. And as that short wave picks on up and as all of this advection, those diabatics increase, it's going to allow the what we call the Pedersen's rule to take place, allowing for that that low pressure system to undergo that cyclogenesis, becoming this baroclinic low, as noted by the advection with the system, creating a thermodynamic and kinematic environment conducive to the severe weather that we're going to see today. And as we continue out throughout the day, that low pressure system is going to slowly move to the east. That cold front is going to continue to advance with that severe weather developing along that dry line. This is a forecasted surface analysis and hazards for about 8 p.m. Eastern Daylight Time, 7 p.m. Central Daylight Time, 6 p.m. Mountain Time, and that warm front still slowly lifting off to the north. And this is later on into the evening, overnight, with that severe weather becoming more of a linear line segment and damaging wind threat. Now, taking a look at our severe weather parameters, the first thing I want to take a look at, our moisture content. This is 2 meter moisture, and as we take a look at this loop right here, you can see a lot of rich, deep Gulf tropical moisture, basically screaming across the southern plains into the central plains today, due to that advection in that warm sector of this developing low pressure system. We have a very strong low level jet that's going to develop due to that cyclogenesis. As that low pressure deepens, is going to reflect up towards the 850 millibar level, where we're going to see a tightening gradient that's going to help with this advection of this rich Gulf moisture from south to north across the region. Is going to help. It's also going to bring some more thermal advection along with that. So with the thermal and the moisture advection across the region, we're going to see increased instability across the region. And we'll take a look at that a little bit later when we take a look at our CAPE values. But again, you can see that deep, rich tropical moisture from the Gulf advecting across the area. That's going to make an environment conducive for severe weather, where we're going to see thunderstorms develop later on this evening. This is at 0Z today. This is 8 p.m. Eastern Daylight Time, 7 p.m. Central Daylight Time, 6 p.m. Mountain Time. You can see behind that moisture, we have this very strong, basically moisture contrast across parts of western Oklahoma and western into almost central Texas, where we have that dry line across the area. And that dry line, that moisture contrast, that really strong moisture contrast, is creating a boundary across that area. And that boundary is going to be associated with the synoptic forcing and lift for thunderstorms later on this evening, because we have southerly winds out ahead of that and more westerly winds behind that frontal boundary, or the dry line that we have right here. And that's creating low-level convergence, allowing for forcing for upward vertical motion, allowing for the development of thunderstorms across this region. Again, you can see those low-level winds from the southeast becoming more southerly across the region, affecting that rich Gulf tropical moisture across the area, where we have dew points in the 60s, approaching the 70s across portions of Oklahoma and northern Texas. And as those thunderstorms continue to move off to the east, they're going to tap into more of that deep, rich tropical moisture across the region. And again, take a look at some of those surface winds across this region right here. 20 knots in this portion of northern Texas, and even 15 to 15 knots and a couple of 20 knots here in Oklahoma. And those strong surface winds are going to be important for tornado genesis with some of those tornadoes that may develop later on today, with a possibility across parts of northern Texas and even across parts of western Oklahoma today. Now, taking a look at our surface-based CAPE, as that moisture screams northward, is going to increase that instability across the region. And as we take a look at our CAPE here in just a little bit, you can see just how unstable the atmosphere is going to be coming. Now, when we talk about CAPE, this is what we call convective available potential energy, is the measure of the amount of kinetic potential energy it is stored in the atmosphere. So any thunderstorms that develop in this environment has all this energy to feed off of. The more energy there is, the stronger the storms are going to be, the stronger the updrafts of the storms are going to be. Now, as we take a look at some of the values of CAPE that we have here, we have values about 1,500 to, there's some isolated areas about 2,500 joules per kilogram of CAPE. Typically for tornadoes, we want to see above 1,000 joules per kilogram. So we got a little bit more than double that across the warm sector of this developing pressure system. But we have seen tornadoes as low as 500 joules per kilogram. So we are well above that across the warm sector where severe weather is expected to develop today. And this is going to be enhanced by that low-level moisture, warm air advection that we were talking about, the approaching shortwave that we'll take a look at 500 millibars, along with diurnal heating and that low-level jet. Taking a look at another measure for instability, this is our lifted index, and our lifted indices values are very unstable across that warm sector and ahead of that dry line, as denoted by this. So we are working with a moderately to a very unstable air mass across much of the warm sector and ahead of that dry line. Now, taking a look at our next indice, this is going to be kind of looking at some of the shear and the instability right here. This is taking a look at more of the kinematic environment that we have. So taking a look at what we have here, this is called EHI, the Energy Helicity Index, and this is taking a look at the lowest 1 kilometer of the atmosphere, so from the surface to about a kilometer up. And this will show us where the best surface instability is, along with co-locating some of that best surface to 1 kilometer shear or streamwise vorticity, which makes it a great indice when looking at the potential and prediction for tornadoes and tornado genesis, since streamwise vorticity shows the low-level winds into the updraft of the thunderstorm that gets ingested into it and then stretched into that updraft, causing the pressure to drop, causing that updraft to lower, allowing for those wall clouds to develop and those funnels, increasing that mesocyclonic rotation, because as you stretch that updraft, think about that figure skater analogy that I was talking about yesterday in the video. So when you have your arms out with that figure skater, the slower they spin. But as you move them on in, the faster they spin. That's what happens when that updraft is stretched. You're decreasing that area of rotation, and then this causes strong vortex suction in the low levels for tornado genesis. So taking a look at our EHI values, I want to take a look here at 0Z. There's strong energy helicity index co-locating some strong surface winds and along parts of western and even northwestern Oklahoma into the southern portions of Kansas. I can see. Now, taking a look at our energy helicity index again at about 7 p.m. Central Daylight Time. Strong EHI values located across parts of western Oklahoma, especially up here in northwestern Oklahoma along the panhandle kinda. You can see this is co-locating again where some of that strong surface instability is, along with some of the best low-level wind shear. So this may be a good factor for tornadoes when storms initially develop across this region today. And then there's going to be a secondary area as we move into the evening, even across parts of northern Texas, I think that we'll have to take a look at. Now, taking a look at our storm relative helicity, our helicity values are basically screaming across the area, and this is due to that very strong low-level jet moving on across the area, creating a big area under those photographs, under that curve across parts of central Oklahoma today. And we can see those helicity values are just screaming well above 300 meters squared per second squared, and that's typically where we want to see them when we're looking at for tornadoes to develop. So anything pretty much above 350 meters squared per second squared is an environment conducive to supercells and potentially strong tornadoes. However, I don't see these storms staying isolated and discrete for very long. These storms are going to congeal into a line very quickly, and we're going to see two linear segments develop as we take a look at our FutureCast radar here in a little bit. Now, taking a look at our surface-based CAPE and our crossover winds. So this is taking a look at some, again, those kinematics and some of that thermodynamic properties with taking a look at our instability right here. Now, those surface winds at 10 meters are coming from the southeast, ranging anywhere from 10 to 20 knots within that warm sector. As we move up to about 850 millibars, you can see some of that low-level jet, 30 to approaching 50 knots across the warm sector from the south. So we have some veering of those low-level winds. And as we move up towards basically 500 millibars, we have about 50 to 65 knots of a mid-level jet screaming across the area from the southeast, becoming more westerly as we move further on to the west. So those winds are, again, increasing and veering with height as we move on up into the atmosphere, creating a very dynamic and kinematic atmosphere for today, for the environment conducive for severe weathers. Now, taking a look at our 850 millibar winds, again, like we have that low pressure system developing across Colorado. We have a tightening gradient across the western portions of Kansas, Nebraska, all the way down into Oklahoma, into parts of northern Texas, with that strong low-level jet evecting that moisture from the Gulf northward in through the southern central plains into the central plains. This low-level jet, strong low-level jet, is also helping increase helicity values, which is basically telling us the tendency for storms to have basically rotating updrafts within this region. So as we increase those helicity values, the better for cyclonic spinning updrafts we have within the warm sector ahead of that dry line for this severe weather event. Now, taking a look at a 700 millibars, I do want to note here, we do have some dry air moving on in. This is creating a elevated mix layer that we'll take a look at a little bit later on when we take a look at our SKUTs. And this is going to help reduce the amount of melting where these storms are expected to initialize, especially across that portion of western Oklahoma where the greatest hail potential is going to be today. And this dry air moving on into the low and mid levels is going to reduce the amount of melting the hail may experience during falling due to the evaporative cooling and the shrinking of the updraft, increasing those updraft vertical velocities, steepening those mid-level lapse rates, these environmental mid-level lapse rates across that area. So this will help promote larger hail growth within that region. Now, taking a look at 500 millibars, we do have a deep long wave trough axis moving on through the western portions of the United States, just west of the Rocky Mountain region, with a lot of cold air spilling in behind that. That cold air is riding up over some warm air, creating a very unstable atmosphere in the mid-levels. That's what's bringing some of those very high lifted indices. As we take a look at our parcel temperature and our 500 millibar environmental temperature, we take the differences between those, and we can see that we have a very unstable atmosphere due to those steep lapse rates developing in that area due to some of that evaporative cooling that we have in the mid-levels. Ahead of that long wave trough, we have a jet max ejecting out east of the Rocky Mountain region into basically the Texas, Oklahoma Panhandle region. That has helped promoting divergence aloft, upward vertical motion, along with cyclonic spin in the atmosphere as we have positive vorticity evection out ahead of that, promoting that cyclonic spin. And again, we have that long wave ridge axis out ahead of that trough axis that's helping evict some of that warm, moist air out ahead of that into the southern and central plains, where we're having that environment develop that's going to be conducive to severe weather. And it's also going to help evict some of that moisture further on downstream of that trough axis, allowing it for that severe weather that we're expected to see tomorrow across the Gulf Coast region, eventually into Florida and the Carolinas as we move into Thursday. Now, as we take a look at our PFJ, there's a lot Now, as we take a look at our 300 millibar chart, there's a lot going on here. There's a little bit of a finger of the Arctic jet moving across parts of the northwest Pacific area into parts of Montana before moving on back into the Canadian prairie, along with our PFJ that's creating that big area of shared energy. As those two jets are relatively close to each other, I think it's within 6 degrees of polar Now, as we take a look at our 300 millibar chart right here, there's a lot going on our 300 millibar chart. We have a very meridional flow going on with our PFJ, with that deep upper level trough and that sharp amplitude ridge developing across the Mississippi River Valley region into the Great Lakes area. But taking a look across the Pacific Northwest, we can see a finger of our Arctic jet across the Pacific Northwest with some diffluent flow up there before moving on up into the Canadian prairie. Then you can see our PFJ relatively close to that Arctic jet, creating what we call a area of shared energy, creating a false jet max within that region. And this is due to those jets being close together, interaction as they are about 6 degrees in latitude close to each other, so that creates an area of shared energy before that trough axis dips to the south with a jet max moving into the base of that trough axis. That's going to continue to deepen that trough axis as the jet max moving out over Oklahoma and Kansas is weaker than the one moving on in. That trough axis is going to continue to deepen and continue to intensify the cold air advection behind that. We have a nice, again, that sharp amplitude ridge out ahead of that with the warm air screaming from south to north, along with that jet max moving into that apex of that ridge. When that does happen, it will then begin to decrease that upper level ridge across the Corn Belt region into the Great Lakes and the upper Mississippi Valley region. Again, across parts of Oklahoma and Kansas, you can see the diffluence of that of the upper level winds through that region. Those winds diverging away from each other. Some of the winds going north and some of the winds moving more northeasterly. That's basically going to cause upper level divergence, creating upper level exhaust for those thunderstorms that do develop in that environment. Now, taking a look at our significant tornado parameter, this is at 7 p.m. Greatest threat for tornadoes is going to be, like I said, that EHI is showing that best surface-based instability, some of those best kinematics with the surface to 1 kilometer shear. Being up here in that Oklahoma, Texas panhandle and still across portions of western Oklahoma where those thunderstorms are going to eventually initialize. A little bit less across parts of Texas, but we'll take a look at that as we move in a little bit later into the nighttime hours. We'll see a little bit difference with this significant tornado parameter. But taking a look at our SKU-T, nice elevated mixed layer, around 700 millibars and 500 millibars, steepening those mid-level lapse rates. That's creating a fatter cape in the mid-levels. That's increasing those vertical velocities with the updraft in that area. That's going to help spin some hail within that area where we could see some significant hailstones. Now take a look at our winds. Surface winds coming from the southeast, turning more southerly, becoming westerly, and then kind of actually backing and then veering again. As you can see here on the photograph, we have a veer type of environment on our photograph. Southeasterly winds at about 15 knots, becoming more southerly at about almost 45 knots as we move into about 1 kilometer above the atmosphere with that low-level jet, and then increasing in speed as we continue to go higher up into the atmosphere. So again, nice curvature in that photograph. Our critical angle is around 53. That's not really that great. I want to see my critical angle is more around 65 to 90. That's a pretty good critical angle. But our storm motion vectors is basically from the southwest to northeast today at about let's see, what's our storm motion vector? About 41 knots, so about 40 knots today. So the storm is going to be moving kind of quickly. And that area under that is our storm relative velocity. And we can see right here, storm relative velocity values is quite big due to that curvature of that photograph right here. 388 meters squared per second square. Anything above 350 is technically supportive for supercell thunderstorms and strong tornadoes. As you can see, we have very high STP within this region of about 6 to 7. So that's a very high significant tornado parameter as noted by this. So as you take a look at this in these box and whisker plots, basically this is an environment conducive to even strong tornadoes, EF2 plus up to EF4 plus, according to these box and whisker plots in that environment. There's a couple of SAR soundings indicating some significant supercells have developed in these environments. A couple analogs for large hail. There's a 4-inch and 2 3/4 inch by these soundings. Again, we have that fat cape that's going to increase those vertical velocities, that elevated mixed layers that's going to reduce the melting of the hail, along with creating steeper lapse rates, allowing for that increase in vertical velocities. Cape around 2,500 joules per kilogram. Those lifted indices, I said, are going to be very strong due to that strong cold air advection moving on in at 500 millibars with that deep upper level trough with that warmer air down below. Again, that's going to be creating lifted indices. -9, -10, forecast values of -12. So very, very strong unstable atmosphere in the mid levels and upward. Again, surface to 1 kilometer shear, 39 knots, very strong. I want to see stuff above 35 knots for tornadoes at about surface to 3 kilometer. So that's very impressive, seeing that at surface to 1 kilometer. Surface to 3 kilometer, 40 knots, and 52 knots at surface to 6 kilometers. So now taking a look at our significant tornado parameter. This is at about 3Z. So this is about 10 p.m. Central Daylight Time now. And you can see that significant tornado parameter has shifted a little bit further to the south, a little bit better STPs now across parts of Texas, but that's moved more into that western and southwestern portions of Oklahoma as we move into the nocturnal hours in that warm sector where we still have some of those very strong surface winds. Take a look at this. Again, steep mid-level lapse rates, elevated mixed layer. That's going to, again, allow for less melting of the hail and to be able to support some large hail with those strong updrafts, keeping that hail suspended. Again, very strong cape, very strong lifted indices. Again, similar shear values. Southeasterly winds at the surface, becoming more southerly, 50 knot low-level jet. Nice curve in our hodograph, becoming more west-southwesterly as we continue on up. And again, still keeping those STP values high, 3 to about 4 as we move into the nocturnal hours. Storm relative velocity still strong, almost 350 meters squared per second squared. So very, very good environment kinematically and thermodynamically to support severe thunderstorms ahead of that dry line in this developing low pressure system in that warm sector. So taking a look at our high-res FutureCast radar for today, as we go in through time, for the most part, we're not going to see much as in for convective activity. Could see some lingering showers around Round Rock, San Antonio, and the Houston area. But I want to take you in through time as we move into about 6 p.m. Central Daylight Time. Let's move on up towards the Oklahoma and Kansas region. Take a look at this right here. At about 6 p.m. Central Daylight Time is about when we'll begin to see some thunderstorms that begin to develop along that dry line area. Near the Garden City, Dodge City, west of Woodward and Buffalo, Oklahoma, near Canadian, Texas, and around Shamrock and west of Elk City, we'll begin to see the first initiation of this line of thunderstorms. And this is going to be around the time where the greatest tornado and damaging hail potential is going to be when these thunderstorms are beginning to develop as they are more singular in nature and more discrete before they congeal into a line. Because as we move in through time to about what is going to be 8 p.m. Central Daylight Time, you can see how quickly these thunderstorms are going to quickly congeal into a convective line segment, one of these QLCSs, these quasi-linear convective systems. And as these storm systems basically congeal into that linear segment, the probability for tornadoes is going to decrease a little bit, with damaging winds becoming the most primary threat. But I definitely cannot rule out the possibility for some embedded supercells in the Woodward to Elk City, down towards the Altus region in western Oklahoma, where the potential for tornadoes and damaging hail I think is still going to continue through this time west of I-35. And even as we zoom on out, you'll begin to see some more of that convective initiation along that dry line, now moving on into portions of Texas. And just watch how quickly the storm system grows upgrowth as we move in towards midnight. You can see that big convective line segment, this linear segment of storms continuing to race eastward, now along the cold front as that dry line begins to retreat back to the west. You'll see the storm system continue to scream off to the east, now around 11 a.m. Central Daylight Time. Places like Wichita, Enid, west of Oklahoma City, Chickasha, Lawton, Wichita Falls, the Altus region, even scrolling on south, you can see places like Abilene now and San Angelo getting ready to be in the path of this convective line segment, where most likely damaging winds is going to be the primary threat as we move into the overnight hours. And I just want to continue this this loop as we watch the system continue on through. This is 1 a.m. Central Daylight Time, 2 a.m. Central Daylight Time. The storm system is continuing to pass on through Oklahoma City, now east of Wichita Falls. This is 3 p.m. Central Daylight Time, 4. Now that storm system is moving into the outskirts of Dallas, maybe weakening a little bit as it's losing some of that energy as we move into the nighttime hours. Now, taking a look at our severe weather threat for tomorrow, again, as this storm system continues to develop today, it's going to continue to push off to the east, where we'll see thunderstorms develop tomorrow across parts of basically eastern, southeastern Texas, and across parts of the central Gulf Coast region. Now, as we take a closer look at the severe weather threat for tomorrow, this includes places like Houston, Port Arthur, Lafayette, Alexandria, New Orleans, Hattiesburg, Biloxi is down here, Mobile, and this is just along the edge of Panama City, all within that slight risk for severe weather tomorrow. Waco, Dallas, Austin, San Antonio, Tyler, Texarkana, Fort Smith, Shreveport, Jackson, Mississippi, and just west of Tallahassee are within that marginal risk for severe weather tomorrow. For the most part tomorrow, the severe weather threat is going to be driven from mostly two parameters. One is going to be, there's going to be the threat for tornadoes tomorrow. There is that 5% contour across the slight risk area. And then the other hazard is going to be the potential for damaging wind gusts tomorrow across that slight risk region, with marginally damaging winds further off in that marginal risk area. Now, taking a look at our severe weather threat for tomorrow, continuing where we left off about 4 a.m. Central Daylight Time. As we continue through the morning hours to about 8 a.m. Central Daylight Time, you see that nice convective line moving through basically the eastern and southeastern portions of Texas, east of Dallas, near Byron, east of Austin, maybe some lingering showers near San Antonio, and just west of the Houston area. As we go to about noon tomorrow, Central Daylight Time, we can see that convective line system kind of along the basically the Louisiana, Texas coast. Some showers continuing to move on through parts of Oklahoma and into Arkansas. As we move into the evening hours, around 4 p.m. Central Daylight Time, could see some convective activity begin to strengthen over Louisiana, where we have the threat again for tornadoes and straight line damaging winds, along with some prefrontal convection that could be happening out ahead of the cold front region that we'll have to watch out for tornadoes, and again, that threat for damaging winds. As we move into the evening hours, this is about 9 p.m. Eastern Daylight Time, some convective activity back in Arkansas, and still seeing some convective activity possible across Mississippi and even across basically southeastern Louisiana, around the New Orleans region. And as we move into the overnight hours, that convective activity is going to continue to push off to the east. Thursday, that storm system is going to continue to push off to the east, with the majority of the severe weather across portions of Florida, southern Georgia, and the Carolinas region, where that slight risk for severe weather is crossed basically central Florida and the eastern Carolinas. You can see places in this slight risk for severe weather is going to include like Sarasota, Clearwater, Tampa, Daytona. This will include places like, I believe, Ocala, Gainesville, Jacksonville, all the way up towards Savannah, Charleston, Myrtle Beach region, and Jacksonville, North Carolina. Raleigh, or Raleigh, however you want to say it, Raleigh, North Carolina, Tallahassee, Palm Bay, Port St. Lucia, within that marginal risk for severe weather as we move into Thursday. And here's your FutureCast radar loop for pretty much Thursday as we continue in through time. Convective activity continuing to push off to the east throughout the day. As we move towards the afternoon, you can see that line of storms across parts of Georgia into Florida. As we move into the evening hours, that system continues to push off to the east with more convective activity beginning to develop by 5 p.m. Isolated severe thunderstorms along the Georgia, South Carolina border, and again, Jacksonville and just west of the Tampa region, with some isolated convection across the central portions of Florida, with that activity becoming more widespread as we move further on into the evening hours, and then that stuff pushing further off to the east as we move into the overnight. A couple of severe weather safety tips I do want to pass on to you guys. Some things you should have before sheltering. If we do have tornadoes today, like we did the other day across portions of Missouri, be sure you guys have things with you such as snacks and water, some food for any of your pets, battery-powered radio or TV as a backup way to get severe weather warnings and stuff like that. Make sure your cell phone is charged too. Something to occupy your children if you have little kids to keep them entertained, because this could be a very stressful situation for them, because a lot of kids have fears of weather, and any basic first aid and med items. I also suggest for something that you guys bring, probably the most important I think to bring too, is a bicycle helmet with you guys, along with some shoes. Most tornado deaths that occur are actually due to blunt force trauma to the head. So having a bicycle helmet, having something to cover your head, will give you a very strong possibility for survival. Now, again, for tornado safety, be sure to stay away from windows. Go to a basement or the interior most room on the lowest floor of a sturdy building. Abandoned cars, mobile homes, and if outdoors, again, seek a sturdy shelter. Again, some things you should know before severe weather. What does a watch mean? A watch means that the conditions are favorable for the development of severe weather, and that you should be prepared. How I like to describe this is you are getting all the ingredients together to be able to bake a cake. Now, a warning means that severe weather is occurring or imminent, and that you should be taking action now. And that's when, after you've put all those ingredients together, you baked it, now you have a cake. So that is my little knowledge for you guys for today, and my severe weather safety tips I do want to be able to pass off to you guys. Again, I want to thank you guys so much for checking out today's video. If you haven't already, like I said down below, hit that like button, subscribe, share this video with your friends and family, allow more people to get this message, and allow this channel to continue to grow, along with following us on social media, checking us out on our website, dynamicweatheragency.com, and visiting us on Patreon to help support this channel. I'm meteorologist James Lawless with Dynamic Weather Agency, signing off for today. We may go live later on today if we see need fit to go live for the severe weather threat across Oklahoma, Texas, across the central and southern plains today. With that, the live stream may be very short today. May just be reiterating what to be expected today, as in for severe weather, as I do have to go back in again tonight and do work with the DoD and the military, doing weather for them. So thank you guys for checking out today's video. I'm meteorologist James Lawless signing off. You guys have a great and wonderful day.